Welcome back to my channel Electronic Science Tutorial. Today is the 11th class of Operational Amplifier. Today I will discuss the integrator circuit by using an op-amp, and from this circuit we can calculate the voltage of the integrator circuit. So without any time waste, let's start our class. So this is the integrator circuit by using an op-amp. Here we use we use one capacitor and one resistor, but the position of R and C are interchanged. The capacitor is connected in the feedback path and the resistor is connected at the input path. The non-inverting terminal is grounded. The input voltage is applied across the resistor and the capacitor is connected into the feedback path. That means the output and the inverting channel. G is the virtual ground point, and resistor, one end of the resistor is connected with the input applied voltage V1 and the other end of the resistor is connected with the inverting terminal of the op-amp. So this is the integrator circuit where we also use resistor and capacitor, but in the differentiator circuit the circuit positions are if we compare with the differentiator circuit, the circuit positions, the circuit parameter positions, that means R and C positions are interchanged. Okay, so now when we applied one input voltage across the resistor, then we calculate the current across the resistor of this circuit. So the input current, the current flowing through the resistance is R is I equal to V1 by R. V1 is the applied input voltage, R is the applied resistor at the inverting channel. So the current is voltage by resistor, that means input applied voltage, that is V1 divided by R. The capacitor is connected across the feedback path, that means the output voltage and the input channel. So the how much capacitor has to be charged up, the capacitor charges to maximum output, that is Q equal to, we know CV. So what is the V? V value is the voltage difference of these 2 points, that is the G point and the V0 point. The G point value is 0 and the V0 point value is V0. So we can write that is 0 minus V0. So Q equal to C into 0 minus V0, that is equal to Q equal to minus V0C, that is V0 equal to minus Q by C. So this is the capacitor charges to maximum output voltage. Okay. Now Q equal to, that means minus V0C. This is the capacitor charge. Now we calculate the current which is given by I equal to, we know the charge with respect to time is equal to the current. So I equal to, we can write dq dt. So dq equal to I dt. Easily we can write this from the above equation. Integrating this dq equal to I dt, integrating both sides, what we get, that is integration dq equal to integration I dt. So what is the value of this integration? Integration dq, that means we can write here q, that is equal to I means v1 by r. So here we put the value of I, that is v1 by r dt. So putting the value of q, what we get? We get minus v0c, q equal to minus v0c. Here we get. So here we write minus v0c equal to integration v1 by r dt. So what is the value of v0? V0 equal to minus 1 by c, 1 by rc, integration 0 to t v1 dt. So v0 is the output voltage which is proportional to the time V0 is the output voltage which is proportional to the input voltage, which is proportional to the input voltage, that is V1, with respect to time 0 to t, and the proportionality constant is 1 by RC. Okay, and why this minus sign is appear? This minus sign is appear because we applied the input voltage at the inverting terminal. So here we write minus sign, here we get. So this is the output voltage of the integrator circuit. So first of all, we have to calculate the current flow through the resistance, that is I, which is value is I equal to V1 by R. Then we have to calculate the capacitor maximum charges, that is the Q equal to CV. But here the V value is the potential difference of the V value, that means the 0 minus V0. So Q equal to minus V0C. We know the current is I equal to dq dt, that means dq equal to I dt. If integrating this equation both side, what we get, that is integration dq equal to integration I dt, then we get, that is q equal to integration, if we put the value of I, that is V1 by R dt. Putting the value of q, here we write, that is minus V0C equal to integration V1 by R dt, and from this equation we get, that is V0 equal to minus 1 by RC 0 to t integration V1 dt. So we can easily integrate the input voltage with respect to time, and this is the proportionality constant R and C value, and this minus sign appear because we applied the input voltage at the inverting input terminal. So here also minus sign is appear. Okay, so this is the integrator circuit, and from this circuit we can easily calculate the voltage. Okay, thank you. If you like, do like, share and subscribe my channel. Thank you.